Today we're working on 2.1 and we're going to be simplifying polynomials. We have two trinomials. They each have three terms. Which terms can you put together? How do you know if you can put a term together? The variables and the exponents have to match. So we take a look at this first one. Does this have a partner in the next set of parentheses? Yes. So pay attention to the sign in the middle. It says subtract. So we're going to take this term minus this term. What is 5x squared y minus negative 2x squared y? How do you subtract the negative? You make it a positive. So it's saying we're going to take 5 and we're going to go the opposite of negative 2. So the opposite of negative 2 is the same as plus 2. So we would get 7x squared y. Okay? Does that term have a partner in the dance? Yes. So we'll do 4x squared y minus negative 3xy squared. And again, that one turns into a plus. So we get 7xy squared. Does this have a partner in the dance? Yes. Negative y squared minus 6y squared would be negative 7y squared. What if I do that and one of them doesn't have a partner? You just leave it. It stays in the equation, and it doesn't really matter where it goes in the equation, especially if there are multiple variables. But anything that doesn't have a partner, you're just going to stick it in the equation somewhere, unchanged. All right. A car rental company's standard charge includes an initial fee plus an additional fee for each mile driven. The standard charge is given by the function 14.95 plus 0.5 m, where m is the number of miles driven. So this is a linear equation. It's saying to rent the car, it costs $14.95, and then they charge you 50 cents per mile driven. Okay. The company also offers an option to insure the car against damage. The insurance charge is 3.9 plus 0.25 m. So if you bought a rental and insurance, how much is it going to cost? How would we do that? So we're going to add the initial charges. So 18.85 plus 0.75 m. So if you rent the car and you pay for the insurance, it's going to cost you $18.85 for the rental and the insurance, and then they charge you 75 cents per mile driven. Okay. All right. So we're going to review leading coefficient and degree. So both the leading coefficient and the degree are housed inside the term that has the biggest exponent. So even though this is out of order, we look for the largest exponent. And that is the leading term. So that exponent is the degree. So the degree here is 7, because that's the biggest exponent. And then the number in front of that term is the leading coefficient, which is 5. And that's important because the leading coefficient tells us how tall the graph is and which direction it faces. And then the degree tells us the shape of the graph. So this is a y to the 7th graph, which means it's shaped like a 7th degree polynomial. And the leading coefficient is 5, which tells us the direction and how tall it is. Or in this case, it's actually how wide it is. So let's look at another one. Okay, what would the degree here be? What's the biggest exponent? 9. And what's the leading coefficient? Nope. So we're looking at this term. Oh. We're looking, now that I broke it, we're looking at this term here. So 9 is the biggest exponent, and -1 is the number in front of the variable with the biggest exponent. Okay, let's do another one. Okay, what is the degree here? The degree is 8, and what is the leading coefficient? 5. Even though the 5 is not at the front of the equation, it is in front of the variable with the largest exponent. So the degree is 8, and the leading coefficient would be 5. So here we're adding these together. That would be -y². Those combine to be 4y, and those combine to be 3. Okay, that takes care of 2.1.